Hey everybody, welcome to the first poster session of ISST 2021. Having a virtual conference and poster session gives us a bit of room for creativity this year, so I'm excited to see what we have. There's a student poster session competition that we've been doing for a while, and that is part of this session and tomorrow's session. I'd like to thank our poster session sponsor, Earthshift Global, for their continued support of the poster session and student poster competition. Earthshift Global has had an integral role in supporting and helping to organize our conference for many years, and we couldn't make this happen without them. Today we have 4 poster presentations. They've requested a few minutes each to discuss their poster submissions. I'll introduce the poster presenters individually. When they join the podium, please introduce yourself, where you're from, and share your screen. After a few minutes, we'll open to a Q&A before the next poster presenter joins the podium. If there's time at the end, other poster presenters may request to also share their work. As with any traditional poster session, please feel free to browse the posters and chat with the presenters. First up, we have Gershons Gubin. Gershons?
Hi, everybody. Good afternoon. Can you hear me? I hope you can. I'm a postdoctoral researcher in the Civil and Mineral Engineering Department at University of Toronto. So let me share my screen, and today I'll be presenting studies here. So I hope you can see my screen. So in this short presentation, I'll talk to you about developing a construction classification system database for understanding resource use in construction, building construction. Okay. So in this study, we're making a new publicly available data set and proposing a new detailed data structure that is based on existing construction management practices. More specifically, we are using uniformat and master format classification systems that are developed for construction industry in North America. In this study, we're investigating how building form and design are driving material use in buildings, and we are looking for opportunities to reduce material consumption. So this study is currently in review in scientific data, and we provide our data set on Zenodo, the data repository. And along with that, we provide a sample code that demonstrates the uses of the data set and the queries that can be performed on the data set. Also, we provide a translation script that converts the data to the structure provided by, proposed by Herring and Fishman in 2019 to facilitate how our data set can be compared to or collated with existing global MI databases. Our method include obtaining building drawings from our partners and also using publicly available drawings. So we have been manually calculating material quantities from 2D drawings using several software like On-Screen Takeoff and AutoCAD. We also refer to building codes such as Ontario Building Code. So we have been organizing our takeoffs based on uniformat and master format. So mainly, uniformat looks at building elements in terms of their functions, while master format looks at the materials that are used in buildings. So for every takeoff item in every building in our data set, we organize them based on this structure that is based on uniformat and master format. And we record them with a data record in our data set, such as this one. So this particular data record corresponds to the amount of concrete reinforcement in the continuous footings of one single detached building in our data set that is located in Toronto, Canada, and constructed in 2021. And you can see that how this information looks in terms of uniformat and master format classifications. This view we call the summary view in our data set. The data structure that I just described is stored in our data set this way. Every building looks like a row in this view. So in addition to the uniformat and master format codes, we store information related to the gross floor area of the building, the type of drawings that we use, like issued for construction or issued as record, the type of buildings like single-family dwellings or office buildings or educational buildings, Every takeoff in this view is in terms of kilograms, and for this particular column, for example, this is the amount of thermal protection on the subgrade walls in the basement of these buildings. Thanks to the data structure, we can aggregate building material information at multiple levels, such as in terms of the materials that are used, or the function of the elements, or a combination of these two. So in this simple query, we show the total amount of concrete that is used in each building element across the database. And in this big pie chart, all of this information is based on uniform math levels. In the big pie chart, you can see that most of the concrete is used in the superstructure of the buildings. And in the small pie chart, you can see a more detailed breakdown that shows that this concrete is mostly used at floor slabs and beams and columns that are supporting the floors. And we provide more examples in the sample code in the data repository that I just mentioned. In this view, you can see the data structure also helps us understand the materials that contribute the most to the total material intensity across building types. This graph shows 65 buildings in our data set in different categories, like mid to high-rise buildings, or laneway suites, or single-family dwellings. And on the right-hand side, you can see the material categories in terms of master format titles. And this graph, for example, shows us the dominant material is concrete reinforcement across the database. Our work also supports thinking about uncertainty and variability in two ways. On the left, you can see the variability within a typology. In this case, it's a single-family dwelling. And this facilitates calculations of uncertainty when doing predictions on material use and GHG emissions. And on the right, you can see that the data structure itself also requires quantification of uncertainty for each material takeoff that we do, based on where the material information is taken from. Is it the original building drawings, or the building code, or the product brochures? So overall, our study contributes to the body of knowledge on material use in buildings, and we are currently mainly working on material efficiency at the scale of overall building and neighborhood forms. And we try to answer the questions like, how do individual elements contribute to material use in buildings? Because we know that understanding material intensities tied to individual different elements can inform changing the building design, and that will lead to reducing material needs while maintaining the same function in buildings. So this concludes my presentation, and I'll be happy to answer any questions that you may have.
Thanks very much. Was seeing if we had any questions in the chat. Not seeing any questions. I'm only seeing a great presentation. Maybe I'll give it a minute for anybody else to ask a question before we move on. I guess if there are no questions, or if you have a question, feel free to put it in the chat, and we'll return to Gershon's later before the end of this. Not sure who we have next to speak. I know that Alicia was having a bit of trouble. So it looks like we've mixed up the order a little bit, but that's okay. Kashayar Ibrahimi,
Yeah.
would you like to share your screen and introduce yourself?
Yeah, sure. Can you hear me, and can you see my screen?
Yes.
Perfect. So, hello everyone. I'm Kashayar, a second-year master's student in civil engineering at the University of Toronto. So I hope everyone is doing well, and I'm very happy to here to give you a brief presentation about prefabricated buildings. So actually, today we are going to answer the question: does prefabrication result in less embodied GHG emissions in buildings? So at first, I'm going to introduce you what prefabrication is. Actually, prefabrication includes the off-site manufacturing of building elements, which will be transported to the construction site for assembly. And the thing is that it is widely assumed that prefabricated buildings can reduce embodied GHG emissions compared to conventional buildings. But all these results and assumptions are based on a limited number of case studies. And also these studies, the case studies use the LCA method in order to quantify the embodied GHG emissions. And as you might know, uncertainty is a part of LCA, which needs to be assessed or addressed during the interpretation of LCA results. So to answer this question and address some things that I just explained, we started with the literature review. So we went through all the relevant studies in order to collect all the case studies, prefabricated buildings. So we gathered all of them, and as far as I remember, we gathered 37 case studies, prefabricated buildings, and all these case studies actually considered a reference buildings, which were conventional buildings, in order to compare the embodied GHG emissions of prefabricated buildings with. So, and also we, as you can see in this table, we classified the prefabricated buildings into 3 levels. So level 2 is the panelized construction, like walls or slabs. And level 3 is the volumetric components, like 3D printed, 3D shapes, bathroom units, and so on. And level 4 is the modular buildings, which all the elements and all these spaces will be manufactured and assembled in the construction site, and then they will be shipped to the construction site. So we have then 3 levels, level 2, 3, and 4. And to address the uncertainty that I just explained, and which matters, we try to assess uncertainty through the use of significance heuristics, which is a kind of semi-quantitative methods that deals with different uncertainty thresholds. So for instance, the uncertainty threshold of plus or minus 10% means that if the difference of life cycle impact of 2 options are less than the uncertainty threshold, it means that these 2 options are quite the same to each other. So you cannot say one option is superior to another. So we did the literature review regarding building LCA to extract these uncertainty thresholds. And as they are very different, and some of them were subjectives, that's why we came up with 3 different uncertainty thresholds, including plus or minus 10%, 20%, and 30%. And one other thing that we considered is that there are different control variables across the case studies. For instance, the type of buildings, prefabricated buildings, were residential, commercial, educational, with different materials, ranging from wood, steel, concrete, and FRP. And all these control variables can affect the final results, which were embodied GHG emissions. So that's why we normalize all the emissions into kilograms CO2 equivalent per square meter, which is actually the most used functional unit across the case studies that we reviewed. And at the last, we calculated the percentage difference in embodied GHGs between prefabricated buildings and conventional buildings. So in this figure here, I tried to visualize the results. The x-axis is the percentage difference in embodied GHGs. So, and it begins with minus 50% to minus 50% to 50%. So the negative percentage means that the prefabricated buildings performs better in terms of prefabrication. For instance, minus 40% means that prefabricated buildings reduce embodied GHGs by 40%. So this is a distribution of the results of different case studies that I explained. So what we found was that using the threshold of plus or minus 10%, the majority of the papers find that either the conventional buildings or prefabricated buildings is actually the same or equivalent, or prefabrication increased embodied GHGs. And also based on our statistical analysis, we found that there is no statistically significant difference between levels 2, 3, and 4, which means that we cannot say by increasing the level of prefabrication, the GHGs will be reduced. So that's the another point that other studies mentioned in terms which they said by increasing the level of prefab, we can get less embodied GHGs, but we found that it's not valid. So the existing published literature showed that prefabrication is not sufficient to strongly reduce embodied GHGs, and also the level of prefabrication is highly conflated with the change in materials, which can also impact embodied GHGs. So thank you so much for listening to my presentation, and I will be happy to take any questions.
Thanks so much for that. That was excellent. Looking for questions from the audience. Yes, it looks like we have. I know there's somebody that maybe has asked a question. I'm not sure if you can see that. There we go. Are you able to read that?
So yeah, in the message box, I can say, how did you locate all of the literature? So I don't know what exactly you mean, but my understanding is that we actually use a set of like keywords to extract all the case studies, and so our main criteria to select the case studies was that we can like estimate or calculate the embodied GHG emissions. And as you know, there are like different system boundaries or different results. But what we actually focused on was to just extract the global warming potential as an important like metric for embodied GHG emissions. And based on that, we were be able to collect all these things. Yeah. So any other questions?
Yeah, I believe there are. I think I can get them to pop up. I'm not positive. I think they were asked in the ask feature. I saw one from Yuan, but I'm not seeing it again. Yuan, if you're there, if you want to join that podium, you could ask it. I don't see it anymore. We have one from Scott.
Hey, can you guys hear me?
Yep.
Yeah.
Okay. Sorry that I can't get the ask feature to work very well. Anyway, I just wanted to say really nice job of implementing the uncertainty significance thresholds in our LCA textbook. It's exactly the kind of thing that we were trying to do. I was curious if you've been looking to publish this, because this kind of chart is the kind of thing that we could really use in sort of updating, making an updated version of that section.
Yeah, thank you so much.
So is that a yes? You've been already published it, and
I forgot to answer your question. So yeah, actually, we're planning to submit like this research as a paper to a journal. Yeah, and I think that would be an interesting critical review paper.
all right, please do keep me posted. I'll put my email address in chat so you can see it.
Okay, sure.
Nice job.
Thank you.
Yeah, Yuan said she submitted one question, and it popped up and then it disappeared. I saw that as well. But Yuan, if you want to jump on and ask, that would be fine. Or we can circle back at the end with a Q&A for everybody.
Am I on the podium now? Okay.
You are, yeah.
Yeah, I get my question is just like, did you distinguish the biogenic carbon and fossil carbon, especially for prefabricated wood material?
Thank you for your great question. No, we didn't, because we didn't have like the available information to do so. because there are different papers with different scopes. And as you said, some of them use wood materials, and as far as I understand, some of them actually considered biogenic carbon for their analysis, but some of them didn't. So, but I think that can affect the results in the whole. But we didn't consider because of the lack of the information available data.
That was yeah. Thank you for the presentation. That was excellent. And then I think we will see who is up next. Let's bring Gershant back. Hi, Gershant.
Okay, hi. So this will be the second presentation. Let me share my screen. Okay, screen 2. All right.
Perfect.
Okay, so in this presentation, I will talk about our study on assessing the environmental impacts of dispersed decision-making in construction projects. So by the time a construction project is built, upfront environmental impacts from design and construction will already be released. And these impacts are driven by decisions made by many stakeholders, including owners, designers, contractors, and subcontractors in the project. And these stakeholders have different responsibilities. They have technical expertise, different technical expertise, and access to data. And their collaboration is usually temporary and varies from project to project. So early stage decisions are very important in construction projects, but these decisions are made before detailed data is available on material and energy type and use. So critical decisions are repeatedly made with partial access to data or authority in construction projects, and there's a mismatch in between among the key stakeholders in terms of decision empowerment and data availability. So in this project, our objective is to advance the understanding of different degrees of decision empowerment, data access among the key stakeholders, and also to provide a framing of division of responsibilities, perception of responsibilities, and empowerment for embodied GHG emissions of the key stakeholders. So in this study, we recruited 25 participants and conducted open-ended, semi-structured online one-to-one interviews. And we asked them questions related to their positions and main duties. By using the transcription of the audio recordings of these interviews, we analyzed them. And in some cases, we had to follow up with the participants. So based on the analysis of the interviews, we aim to provide some recommendations and the framing of division of responsibilities as I just described. Recruiting the participants included many different platforms, such as U of D's Connect platform, LinkedIn, our personal networks, several associations, CSCE bulletins, and we have been looking for 1-year experience in the job, and all the participants were in Canada. They provided us a signed consent form, or they provided their verbal consent during the interviews. We conducted the interviews in between April and June 2020, and in February and March 2021. And in this graph, you can see the participant roles and the company types that they are working for. So of the 25 participants in total, we have talked with 5 designers, 5 estimators, 5 subcontractors, and in total, we have interviewed 10 project or construction managers or site superintendents. So this graph shows the participant roles and the scope of work that they have been doing. So most of the participants that we have talked with are working in the industrial, commercial, and institutional constructions, which is followed by commercial and residential and infrastructure projects. And when we look at the years of their experience, we can see that over 80% of our participants have been working in their role for more than 4 years. The type of questions we asked included their years of experience in construction, the scope of work they have been doing, their typical work duties, and when they get involved in projects typically. And with the designers, we wanted to understand the decisions that are made in each major design phase. With the estimators, we wanted to understand the inputs the estimators are working with and how they develop their estimations. With project managers and superintendents, we asked questions about decisions they make on methods and supporting materials and tools on construction site. And we wanted to learn how they collect data during construction. And with subcontractors, we wanted to understand, again, how they make decisions on site and what drives drives changes in the way that they perform their work. And there were some common questions that are asked to all of the participants, like who they interact with the most, do the environmental considerations factoring into any decisions like GHG emissions, or which factors make them use more materials than what was designed, if they're using building information modeling on site, or how they are managing their waste on construction projects. And so we are currently in the stage of analyzing our interviews, and we have some preliminary findings. First, the findings showed the importance of government mandates or certifications like LEED. And participants stated that no information will be collected or prepared unless it is asked in the contracts or it is mandated. And we realized that there are some differences across provinces. For example, there's less recycling facilities available in New Brunswick, which affects the waste management in projects. And the results also show the importance of early stage decisions, which can impact the material selection or going for prefabrication in the project. Most of the project managers that we have interviewed think that the designers or architects are responsible for incorporating GHG emissions into choices or decisions that are made. And the importance of LEED projects are emphasized, especially in terms of using multiple bins at site for recycling and managing the waste. And most of the participants stated that decisions are usually cost-driven. So if they're deciding for an alternative, it's mostly cost-driven. There should be either a schedule or cost advantage to be able to make that decision. And they stated that better procurement methods are needed, not just going for the lowest price in the projects. And also, they emphasize the importance of going for local contractors that have the local knowledge. And this concludes my presentation. I would be happy to take questions now. Thank you.
Hey, Gerson, thanks. That was excellent again.
Thank you.
Looks like we have a question from Julie in the chat. And she said, because you used the semi-structured interview, I wondered, did you or are you going to use any specific qualitative method to analyze the results from the interview?
Thank you for this question. We are planning on analyzing the results compared with the literature review. And after analyzing, going through the interviews, we plan to maybe go back to the participants with some additional questions. So every interview takes about 1 hour. And these people are really busy. I mean, they're from the industry, and it was really hard to schedule an interview. So if there are some missing points or some of the topics that we want to look into in more detail, we will need to go back to the participants and talk with them again.
And that, I think, feeds really well into the next question. Scott Matthews wants to know if you could talk a little bit more about how you got the respondents. So
well, that was quite an adventure. So I had to use the personal networks of the professors in my group. I had to send a lot of cold emails, so we have this alumni platform at U of T. So we have sent out messages to the alumni who are working in the construction industry. I have used my personal network as well. So the participants are across Canada. So it has, I guess it has been mostly U of T alumni, but we had to look at multiple platforms to find people. And sometimes some of the participants helped us find other participants. They're friends from other companies or at different roles. How representative our sample is? So I think it's quite representative because it's randomly selected, and we were aiming for in total 25 participants in 5 groups. So and they are chosen from different parts of the country, working at different roles, working in different companies. So I guess it's pretty representative.
Would you worry about any sort of bias if everybody had a U of T connection?
Not everybody has a U of T connection. So some of them have their bachelor degrees from U of T. Some of them have their graduate degrees from U of T. And they even if they're alumni, they are working at different companies in different parts of the country and different sectors. So some of them are working in heavy civil, while some of them are working in residential construction, for example.
Okay. Thanks. It was
Thank you.
a great presentation.
Thank you.
Again. And with that, I think that, if there are additional questions, please feel free to reach out. I think that we have another presenter. I'm not sure if we're going with Parth or if we're going with Alicia, but we'll find out.
Okay.
Hey, Parth.
Hi. Just gonna share my screen. There we go. Is the
Looks
screen
good.
visible now?
Yep, looks good.
Okay. So, good evening, everyone. This is a study that tried to look at what would happen if cargo ships calling at major ports in India plugged into the electricity grid instead of running their engines when they are in port in order to generate electricity to power things like the ship's lights, fuel pumps, air conditioning for the crew, things like that. The motivation for the study is that shipping contributes to a large amount of premature mortality globally. We've done some previous work which suggested that shifting shipping from burning fuel on board to electricity is beneficial in a large number of ports in the US, not just in California, where it's slowly becoming mandatory. And our reasoning was that ports in India are close to cities that have very high population densities. So by way of comparison, Mumbai has a population density of over 25,000 people per square kilometer. The population density in Los Angeles or New York is a third or a quarter of that, and those are fairly densely populated cities. Another part of the logic was that as of 1st January of 2020, ships in ports that are outside the United States and Europe are allowed to burn fuel with 5,000 parts per million of sulfur. In contrast, you're allowed to burn fuel with only 1,000 parts per million of sulfur in ports in Europe and North America. And of course, if you compare that to road diesel, that is in fact just a very high sulfur content for the fuel. Another sort of practical impetus for the study was that the government of India is actually promoting shore power in a number of ports. And so we wanted to check whether this made sense. one of the problems with doing this kind of analysis, which we encountered when we analyzed US ports, also is obtaining data, obtaining vessel call data. In the US, that data was impossible to get from the ports, and we had to buy it from a third-party provider. In India, Priyank Latwal, who's the student who led this study, sort of did an incredible job beating down doors at the Ministry of Shipping, at the Coast Guard, in different parts of the government of India, and actually managed to get primary data on close to 22,000 vessel calls made by close to 6,000 ships between 2017 and 2018 in India. The analysis of this data revealed a couple of interesting things straight away. So, for example, ships stay in port in India much longer than they do in the United States. So the median at-berth vessel call duration was around 40 hours. It's less than half of that in the United States. So if you were trying to reduce emissions at the port, improving port efficiency is something that that we saw would be beneficial without doing any analysis at all. What we then did was to estimate how much these ships would emit when they're in port. This required doing some analysis to find out the details of each one of the ships that called. So Priyank built a web scraper tool that identified these ships and got some of their vital statistics, so to speak. And he used that information to estimate how much fuel they would burn in port and how much electricity they would need if you switch them to electricity instead. And by comparing both of these things, we could actually work out how much you could reduce emissions by shifting to electricity. So the first result was actually looking at how much these ships contribute to the emissions in the area where these ports are. So we compared the emissions from these ships to the EDGAR database, which gives you gridded emissions across the world for different pollutants. And we saw that these vessels are in fact not very significant contributors to urban air pollution in Indian ports, with the exception of NOx in some of the ports in India where the ships are responsible for a substantial share of pollution. We also found that if you switched from the kind of fuel that you're required to use from January of this year onwards, so relatively low sulfur marine fuel, fuel with 5,000 parts per million of sulfur, then shifting to electricity actually does not actually reduce emissions by very much. It does not actually reduce premature mortality by very much. And there are places in India where the dominant fuel is lignite for electricity generation, and in those places you would actually increase premature mortality. We had some estimates of what the effect on premature mortality would be, but we kind of used a heuristic method to arrive at that. And so we haven't put the numbers here because we aren't terribly confident in them. But right now, it turns out that shifting from fuel to shore power in India does not do a whole lot of good because the electricity grid is simply not clean enough. Most of the load following electricity, or virtually all the load following electricity in India, comes from coal, which is unabated. And that is what is driving this result. Finally, we did an economic analysis, which you don't see on this poster, of what the benefits and costs to the ship owners would be of switching from burning fuel on board to coal. And they do save some money, but the amount of money saved is simply not large enough to justify the cost of retrofitting the ship, given the age of the vessels that are serving Indian ports. So our conclusion was something that we had not anticipated. It turns out that the electricity grid in India is simply not clean enough to justify a shift to shore power. To the extent that the government of India wants to commit any resources to cleaning up air quality, the focus should be on cleaning up the electricity generation mix. That is pretty much all I have. I'll take any questions.
Hey, Parth, that was great. Let me check the chat here. It looks
Derrick,
like Michael Craig. Hey, Michael.
Hey, that's me. That's me asking the question. Parth, nice talk. Great to see you. And great work by your student getting all that data. That's pretty crazy. Can you please remind me again how you went from the emissions to the health burden, like premature mortality, for instance?
Yeah, so there are. I can send you the paper, but there's basically a heuristic. Someone ran an air quality model for different parts of the world, and produced these estimates saying that if you change the background emissions in this region by X%, then the population weighted change in mortality is Y. And there are huge error bars on all of that. And so we use the results of that paper to produce an estimate. If you wanted to do this properly, you would have to run a chemical transport model and calculate changes in concentration, and calculate intake fractions and so on, and basically build a reduced complexity air quality model for India, which I know some people are doing. Does that answer the question, Michael?
He stepped off the podium, so I'm hoping yes, but he can jump back on if not. I have one in the chat from Scott Matthews, who said, it's been good to follow this work over the past years. I don't think I've ever asked what a typical cargo ship would need to do to use shore power. Is this an easy add-on, tech and cost? How much per ship?
Yeah.
It looks like you maybe responded to Scott, but it would be interesting maybe for the rest of us. And Scott is here if he wants to add anything to that.
So any kind of hydraulics, lights, air conditioning through cabins, if you have to move goods about the ship, winches, motors, all of that requires power. For a container ship, it would be of the order of about 500 kilowatts to a megawatt of power. If you had an oil tanker, and you have onboard pumps, then it is 3 or 4 megawatts. For a cruise ship, you're talking 10 to 20 megawatts, because you have to keep all the cabins air conditioned in what's basically a small city. So it's a substantial amount of power. What it costs to retrofit depends on the size of the ship. For this, the lowest estimates we've heard are around 300K for a ship that's pulling a couple of 100 kilowatts. The largest estimates are 1.5-2 million. So there's kind of an order of magnitude range there. And the infrastructure on the port is pretty expensive also. So we're talking a couple of $1 million per berth that you retrofit, not counting whatever you need to do to actually enhance the port infrastructure itself, because the port may simply not have the ability to supply 2, 3, 4, 20 additional megawatts of power.
All good. Thanks, Parth.
Yeah.
Great job.
Thanks.
Michael Craig said that thanks for the answer. Yes, you answered the question. So I think, if there are no more questions, or if anybody has additional questions, we could circle back at the end with everybody. But I think we have one last presentation. We've been having trouble getting Alicia to connect, but I think that Mike Chester will be joining me here in a second to play a video recording of her talk.
All right, so thanks all. I didn't expect 5 minutes ago, 3 minutes ago to be doing this, so give me a little slack. So Mikhail Chester, Arizona State University, happy to be joining you. Alicia Helmrich is a PhD student with us, soon to be graduating. And for a while, Alicia and I, and as well as our broader lab, have been debating this question of centralization and decentralization for resilience, resilient infrastructure. So a lot of times we hear statements like, decentralization is synonymous with resilience. And we wanted to unpack that a little bit to sort of get some context here. What do we even mean when we use those words? Do we mean the same thing when we're talking about infrastructure versus the governance of infrastructure and so on? So Alicia recently published a paper on this topic, and she recorded her presentation just in case this happened. And I'm going to play her presentation for you now. Yeah, guys, and actually, I'm not sure this is going to work because I've got to give Apple permission to do all this.
Hey, Mike, if we can't make this work on the fly, we have another session tomorrow. We can get like an MP4 video or something. We can convert it and play it tomorrow.
Let's try that, Derek. Let's see if we can give her some time. Yeah, I've got to set up permissions and all that, so it's not letting it happen.
No, that's fair. I appreciate you trying to step in with the technical difficulties, and sometimes it just doesn't work. But we've got another session tomorrow, which is great. So thanks for giving it a shot, and sorry that it didn't work, and sorry to Alicia, but hopefully tomorrow we can get things straightened out. But we do have a tab on the side for the posters. If you guys would click on those and check out the other posters that have been submitted. We do at the same time tomorrow have another 3 or 4 presentations, and anybody else who's submitted a poster, if you would like to and haven't signed up to say a few words about it, you're welcome to join us either now or tomorrow. Otherwise, I think that we can bring this session to sort of a formal close for me, but feel free to hang out and chat with the poster presenters, and please check out all the poster submissions. Once again, wanted to thank our sponsor, Airshift Global, for sponsoring the poster session and the poster competition. We couldn't do it without them. I'll check now and see if anybody had any other housekeeping. Beth or anybody else. Otherwise, I will bring this session sort of to a close on my end. But please feel free to hang out and mingle with the poster presenters or anybody else in the session. Thanks to the presenters again, and hopefully we can get Alicia's technical difficulties figured out.